lovely. Welcome back to Apeira Astra After Dark. I'm your Celeste, and tonight we're leaving Earth behind for a little while. Curiosity has found something rather beautiful and rather mysterious high on Mount Sharp. High on the northwestern flank of Mount Sharp, Curiosity has driven straight into a sea of tiny polygons. They fill every direction the cameras can see. Dark seams and low ridges divide the ground into thousands of little cells. 4-sided, 5-sided, 6-sided, none of them perfect, yet together they look almost tiled. Each one is only 4 to 8 centimetres across, small enough to hide under a coffee mug. The grandeur comes purely from how many there are. The pattern even climbs the lower slopes of a nearby sand-capped butte called Miraflores. Project scientist Ashwin Vasavada said it best. This sea of polygons took our breath away. And darling, he wasn't exaggerating. What looks like a crack isn't always a crack anymore. On Mars, fractures can open, fill with sediment or mineral-rich water, harden and then stand proud once the softer rock around them is worn away by wind. So the raised edges we see today may simply be the ghosts of older openings. Curiosity has watched this happen before. Years ago at Yellowknife Bay, it found resistant ridges with chemical layering thinner than a human hair. Quiet proof that fluids once moved through the rock long after the fractures first appeared. Valle Grande might be recording 3 chapters at once, the moment the ground broke, the later episode when something filled those breaks, and the much more recent wind that carved the landscape we see now. Clever little planet, isn't it? There are 3 main ways to make a polygon field like this. First, a simple drying, water-rich mud shrinks, tension builds and the surface cracks into cells. Early cracks often meet in T-shapes. Repeated wet-dry cycles can gently push them toward those elegant 120-degree junctions that look almost hexagonal. Second, thermal stress. Rock expands in the heat of day and contracts in the cold of night. Over enough cycles, the stress accumulates and fractures appear. Third, burial and compaction. As younger sediment piles on top, the deeper layers get squeezed, pore water is pushed out, and new fractures can form far below the surface. None of these rules the others out. Mars is perfectly happy to stack them one after another in the same rock. Rather thorough of it, don't you think? The cameras show us the geometry. Chemistry will decide the story. Curiosity is carefully comparing the raised ridges with the material inside the cells. Mastcam for shape, the hand lens camera for texture, and both APXS and ChemCam for elemental differences. A consistent chemical contrast between edge and centre would be far more telling than any single measurement. This isn't the first time the rover has met polygons. At Old Soka in 2016, it found tiny drying cracks in ancient mudstone. At Pontour, it found sulfate-rich ridges that seem to record repeated wet-dry cycles. Valle Grande is different mainly in scale and continuity. The pattern surrounds the rover completely. Whether that means one vast event or several overlapping histories is still an open question, and I rather like that it is. Gale crater was chosen because its rocks keep a vertical diary of changing environments. Lakes, groundwater, drying, burial and wind. These polygons add another page. If they are desiccation cracks, they mark a time when wet ground became dry across a remarkably continuous surface. If they formed deeper under burial, they record the weight and fluid pressure of overlying sediment. If thermal stress dominated, they speak to conditions closer to the surface after the rock was later exposed. Most likely the truth is a hybrid, sediment deposited, fractured, invaded by fluids, cemented, then slowly scoured into the honeycomb we see today. 14 years after landing, Curiosity is still doing what it does best, turning a landscape that looks self-explanatory into a set of careful, testable comparisons. The geometry is already written. The rover is simply working out which chapter of Mars wrote it. And that is where we leave the little polygons of Valle Grande for tonight, still keeping their secrets, still waiting for the next set of measurements. Thank you for wandering the Red Hills with me, my dear. Sleep tight. This is Celeste on Apeira Astra. I'll see you again after dark.